All right. Thank you very much for all the people who are here. I'm still waiting for one more panelist who's probably just now walking into the room. Yes, so there's Albert. Right on time. Perfect. Here, we all want to create hopefully lively, thought-provoking discussion on role of standards, right? Just have an open discussion on the role of standards, how they play a role or not in the evolving AI hardware landscape. I really want to see, to explore how these standards influence innovation, adoption issues, technical direction, and we are going to get it from a diverse set of panelists here, right? We have ARM kind of from their point of view on IP portability. We have Cadence from a point of view of just EDA tool innovation. We have Synopsys here from a point of view of both tool development innovation and the standard side of things, and academia in the form of the research and validation, right? Now, I just want to introduce myself. I'm Nagu Dhanwada, and I'm with IBM for my day job. I deal with the tools and models relating to power, thermal reliability, and methodologies there. And also, I do have a standards hat where I work with SI2 on all our UPM models, and also chair the IEEE 2416 power modeling side of things, right? Now, let's get into the agenda for a minute. Let's can we go to the slide? So I do want to start it off with a poll to the audience and the panelists here, right? And I hope people do participate so that we get a sense of where things are. That's how I want to actually start. And we'll give some time for our panelists to introduce themselves. I'll have a kind of a rapid fire and role reversal section. We'll have a few mini debates. And I'll see if if we have an interactive set of audience, we'll try to get people in terms of getting some audience Q&A. And is there a change my mind? I want to see if there is a change my mind section where we can get panelists or others to change their mind on what their viewpoints are, and come up with the standards wish list if we can. Yeah. So that's at least the way we think we'll go through the panel today, right? So can we quickly get into the poll, Ali, right? I mean, if so really, I mean, it's you can I could have softened it, but really our standards killing innovation. I mean, I added the AI keyword, but really our standards killing innovation. Do you agree or disagree, right? While we wait for the audience to respond, let's just get the votes from the panelists, and then of course we'll get into the introduction. But Albert, your vote. Agree or disagree? Up or down?
Agree.
Agree that they are killing innovation. Okay, good.
I'm
Right.
going to disagree.
Oh, you disagree. Okay.
Disagree.
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 Okay, so we have three disagrees and then one agrees. Okay, good. That's from our panelists, and let's just wait. Yeah, let's wait a little bit and encourage people to vote on it, and then we'll
Give a real-time update.
We'll take it from there. Yeah. So maybe while we wait, we should probably do the panelist introductions. Maybe that will give a little more time for people to vote. Yeah. So why don't you start, Albert, introducing yourself?
Sure. Yeah. My name is Albert. I'm a senior engineer group director from Cadence. Currently the R&D manager for Cadence on-chip PDN EMR analysis tool Voltus, thermal analysis tool Celsius, as well as a data center thermal analysis tool Reality.
Thank you.
I prepared like a minute introduction. I'm going to feel really bad for talking so long, but so I'm Rhett Davis from NC State. As an academic, sorry, as a graduate student, I was appalled when I learned that the majority of chips that were being designed in academia just didn't work. And so I set aside my design tasks and I started focusing on enablement. And I found by far the things that helped me the most in enablement were the standards. So then as a professor, I got involved as many standards as I could. I was one of the first academics to start using open access, which I made the centerpiece of the popular 45 nanometer FreePDK. And then later got involved with U for about 13 years now, working as part of the Low Power Coalition, and then later as UPM in 2416, mostly doing proof of concept studies. And also in that time, I've been working on the Open Model Interface Standard from Compact Modeling Coalition for reliability simulation. I do most of the technical writing and coding for that group, and more recently gotten very interested in the SI2 AI ML schema working group.
Okay, thank you, Ray. Amit?
Hello, everyone. I'm Amit Srivastava. I'm R&D engineer architect at Synopsys, currently serving as the vice chair of IEEE 1801 UPF working group. I have more than 20 years of experience in the low power verification area and have contributed significantly to the UPF standard, notably UPF information model and more recently refinable macros. I'm excited to be here and looking forward to sharing my insights on how standards enable AI innovation.
Good afternoon, everyone. I'm Sri Chilkuri, Director at ARM. I'm leading the sign-off solutions team, where we are developing electrical integrity-based sign-off solutions, primarily static timing analysis, power estimation and verification, and PDN, IRE, and EM sign-off. I've been involved with the SI2 team in advancing the IEEE 2416 for system-level power modeling. So I'm here to, I'm excited to be here, and I'm hoping I can learn a few things from the team.
Thank you very much. So we have a great set of panelists here, and we have results from the poll. Okay, so I think we have a friendly audience here. So okay, so I'll take that. Let's roll with it. So including the 3 more votes we got from the panelists, we are probably a lot of people do agree that standards are helping. Yeah. So let's use that as a baseline, and probably we can go back to the agenda and leave it there. So first, I want to get into what I think we call as a rapid fire and role reversal segment, right? So I'm going to ask questions to each panelist, right? So I'll start with ARM, right? How significantly do standards reduce your effort in supporting multiple tool flows? I mean, any specific benefit you see? What's your take?
So at ARM, as a IP provider, we want our solutions, whatever our IP that we're designing, to work with multiple tool solutions, multiple internal solutions that the customers have, which basically means any methodologies, any design that we do, it needs to be vendor agnostic or vendor neutral, and it needs to facilitate that integration with the ecosystem, whether it is the customers, their own internal solutions, or in the case of chiplets and whatnot, where if they are working with other teams, they need to make sure it works seamlessly, and they don't actually have to spend a lot of effort and bandwidth to kind of integrate these solutions. So we believe that the standards actually help facilitate that. And we think, having a more robust interoperable solutions and the standards that actually can be developed at a faster pace will actually help facilitate, develop a very flourishing ecosystem.
Thank you, Sri. I'm going to go to you, Albert, right? So can you share an instance where standards got in your way? Right? I mean, I think it probably created more problems than helped.
Yes. So I can share a story from the thermal side.
Okay.
I think on thermal, I think traditionally, like ANSYS have ASPAC and Siemens have Floatum. And for the system designer, they usually get a model from the chip designer in one of those two formats, and then use that to do the system level analysis. So there was a standard called the ECXML file that actually proposed by the company that we acquired called Future Facilities to just try to break the barrier. But a lot of times that we face the problem in that is that the ECXML file, the first version, has a lot of things details that doesn't include, that customer have problem to use that model. Then to have those added to that ECXML, it just take almost a year or two to get those into that, because people have to discuss and vote, and then we have other tools need to support that. It's a really long journey of that. So I think, but from outside is when we work with the customer, they want to solve the problem today. They have the tape out in 2 weeks or 3 weeks. They don't have that much time to wait for those. So I think from my point of view is if all the standard taking such a long time to take a new input, it's really standing in the way of being deployed. But on the other side, if we have some flexibility in the standard that have some customized area fields that we can add it to those, then probably it's easier to adapt to the customer needs, and then gradually we can put those into the standards. So that's basically my point of view from my story in the past.
Okay, thank you. Amit, to you, right? So how can, let's say, any IEEE 1801, you're involved with it, right? Or any other standards guide the product roadmap development, right? And basically, do they help guide any additional features in a product? And does it really, I mean, can we think of it like democratizing innovation, right? Is that something you can shed some light on? Is that?
So at Synopsys, our product roadmap starts with customer requirements, and whenever we get the requirement, we first look at the existing standards to see if the standards already support it or not. If it does, we then align our tools immediately to be compliant with the standard and then kind of make it available to the customers. But there are situations where some of the standards may not have that feature available yet. So that is where we then look at basically how we can address the customer requirement with some custom extensions. And the good thing with UPF is that it does allow you to have some custom attributes that can be specified, which you can use. And so that's what we leverage it and provide a solution. And then after that, we then go back to the standard and try to enhance it. So I can cite one example there, like some years back, we had a request from customers to check for the availability of supply rails on a chip. And at that time, the UPF did not have that capability. But UPF had a capability to define custom supply set handles. So we leveraged that, we addressed the customer need, and then we went back to the committee and standardized that. And then it came to the standard as available supply. So the good thing is that if the standard provides you those custom extensions, we use that to address the immediate needs, which Albert was saying, that you need the solution now. You don't want to wait for years for the standard to come out. So we leverage that, but with the eventual goal of standardizing it. And that's where the democratization of the technology comes in, where you can solve a problem, you create a proof of concept, and then make it available for everyone to use.
Great. Thanks, Amit. So to you, Brett, right? So let me ask you, where have standards helped you, to get from your research ideas? Did they help you get from your ideas in your research lab to getting it out there and be used? Anything you can share there?
Well, I think the one that immediately comes to mind is doing the 3DIC work that we've done in the past. We wouldn't have been able to do that if we hadn't had open access, for example, and the scripting frameworks that were there to build everything up. I mean, when you're an academic, you're always kind of trying to walk this tightrope. You have to get the chip out, and you have to do that before the student graduates, and with enough time to actually write the paper so that you can motivate someone to pay you again. And in the midst of all this, the tools keep changing and the technology keeps changing. So you need something to kind of hang on to so that you can train the next batch of students. And so the standards are something that's not actively changing to try to differentiate itself.
Okay.
So that kind of ends up being this thing that you can hang on to make sure that you can execute on those things.
Open access is a classic example.
Open
for
access
you-
is a great
for you to get there. Okay, that's awesome.
Mhm.
So now I'm going to hold Albert. I'm going to flip a perspective here.
Okay.
I want you to argue Arm's case of why you see, hey, let's say you are Arm now. So I would want you to argue and make a case for why standards are important, although that's not your stand. And then I'm going to go back to Sri and say why, argue Albert's point, you making an argument, right? So
Okay.
so
Yeah.
so you are Sri now. I mean, you're Arm now.
Okay.
So,
Yeah, either Arm or maybe let's put me as a foundry. For example, because I'm dealing with foundry most of the time. So like for 3D IC, right? I think there are different ways of describing. A good example is that there's a different ways of describing the 3D IC stacking and how the bumps are mapping with each other or different checks. I think in the past is almost every tool has their own way of describing it. As a provider, as a foundry, if I have to, for every tool I have to provide one of them, that's a cost on their side. And even from their side, if for example, like for the EMR side of solution, for example, like Red Hawk has their own library and Voters has their own library. On my side, if I have to characterize everyone for different needs, that's a really burden, the cost from the foundry side, not just at the machine cost, but also at the cost to their project, right?
Yeah.
So from their point of view, of course, I think having a standard, all the tools follow, and can minimize the work on their side, and also can minimize not just the work of generating those, but also minimize the work of validating those libraries or files being created. So I think, yeah.
Okay, that's I agree, right? I mean, you need an XPGV, you need something else, at least in the power grid space, which you find you have to do that. Okay, good point. Now, Sri, you're running a fast-paced EDA team, right? So
So as an EDA vendor, I do realize that my customers' needs are really trying to put their products first, right? Obviously, they're going to ask for feature extension or a new feature or whatnot, which they really need it in the next few weeks or months even. But at a standards body, usually it kind of takes quite a bit of time to align all the other parties involved. It's not just about one or two teams aligning together. It's actually getting the entire standards body to align. So as a vendor, I would obviously put the customer's needs first, obviously, right? But I would actually try to not make it entrenched, really. What I mean by that is any extensions I build, really, I need to make sure that these are short-termed and these are actually things I take it immediately to the foundation standards body and kind of expand on it and kind of get that going. Otherwise, once this extension is entrenched in the industry, it's nearly impossible to change it. And another example I would quote, SDC is a very good example, right? There's several extensions from each vendor which are now so entrenched that people don't even want to change those things. Right?
I see. Yep. Good point. Yep. Okay. So now we'll try to get into the mini debate section. Yeah. Let's see. So I'm going to actually start with probably the point you brought up, right? So I'm going to start there. So are formal standards even the wrong approach, right? I mean, there's a whole open source tools. I know Andrew is here. There's a whole open source tools versus control standards, right? I mean, is that what's your perspective? I'll start there, right? I mean, let's.
Yeah, I mean, certainly there's a lot of people who feel that formal standards are the wrong way, that we should be having de facto standards, that really the thing you should do is take stuff, put it out in the open as quickly as possible so that people can download it freely and use it without signing any license agreements. And that should be the way that we should do everything. In fact, I mean, I have many thoughts on this, but I'm going to see if I can get this as argumentative as possible here.
I want others to, I mean, who are really making chips and making things working,
Right. So we'll start off with that.
Okay, that's your
and see how.
Let's
prove me wrong.
I think there is value in both, like formal standards kind of bring together a group of experts and basically to build up a consensus and agreement that, okay, this is what you want to standardize and come up with a proposal. But then if you have a way for general public or your users who are not part of that initial discussion to contribute, that kind of basically helps get the best out of the both worlds. And I can give examples of UPF where it's basically start in the IEEE committee and basically meet weekly and brainstorm on different ideas and develop features. But then there are mechanisms for users to basically contact the committee through the email alias and also like through public forums. And that is where we also take in the input from that side. And a good thing about UPF is that UPF and some of the other IEEE standard is that the latest revision is available for general public through IEEE GET program for free. So everybody can access. There's no need to sign up for any agreement and all. You can get the latest revision for free. And that is provided through Accelera. So
you can get the latest version for free once it's done, but when it's in the process of being developed, you can't go to the meetings unless you're part of the IEEE SA.
That is true, but there is always kind of email alias available for general public to comment and contribute. And this time around, with the latest UPF 4.0 revision, we're also providing an open access website link for UPF. There we'll publish the examples from the standard, and in future we plan to enable general public contribution as well. So I believe the best of both worlds is what will get the best out of the standards.
Yeah, well, to keep playing the devil's advocate here, I mean, once the standard is done, then you have to go build the tool. And once the tool is built, then you have to license it from the person who's selling it, from the vendor, and they might not want to give it to you for free. And your budget is so small, that can stifle innovation. So
there are different kinds of tools available. So and obviously there is some commerce involved, but yeah. I think it's what it is there right now. So
right, but that's the argument. The argument is that you stifle innovation by putting that wall up and forcing people to sign those license agreements. I mean, I often say that the legal hurdles are greater than the technical hurdles sometimes. But prove me wrong.
Legal things, right? It makes sense that a standards body needs to have a business side of things, right? Because if it doesn't make financial sense for customers or vendors or anyone, then it's really not going to go much further, right? So, developing the standards should include the business side of things. And, obviously, one of the value propositions that needs to be given is, the business and technical side of things. And that goes for both, all parties involved in that, right? And I think one of the things you mentioned was some of these are not available until the final spec is released. But maybe there needs to be a business side for early access with, maybe, appropriate clauses or whatnot, right? So, but there should be an appropriate business side to things, which is what will get the ball rolling, and not have the parties go off on the side and develop extensions, really. And that's really the key.
Right. I mean, I'm kind of enjoying this, playing the devil's advocate, I got to admit. But, a good counterexample to this would be Spice, which was originally released open source. That didn't stifle any innovation. You had MetaTools, which came along and, commercialized it by nothing other than a business plan to fix the bugs and sell that. And then all the other vendors sort of came out with their own versions. And that was a case where something that was fully open source, sort of became a de facto standard and didn't stifle innovation, didn't need any formal process for. Maybe that's the exception rather than the rule. I don't know. But,
yeah, I totally agree with the three. Is for any standard, it has the side of a business in mind. Like for example, for EDA, it's pretty much consolidated with the three major companies, right? They all trying to in order to maximize their own business. They're all trying to build their own ecosystem, having their own format, having all their like all the tools talking with their own data in the most efficient way. In order to convince them to break that ecosystem and to adopt open standard, there has to be enough business impact that can convince the company to do that, convince the group, right? Either you from the customer point of view or from the foundry point of view to push that. That's a good angle, but from the university point of view, it's really hard to make that argument. Yeah.
But that good points. I'm going to flip to the second mini debate, right? So we were. I think I kind of heard from Albert and a little bit you mentioned. Hey, you probably portrayed non-standard extensions as a feature of UPF, right? So really, are non-standard extensions really enablers, or they are a fragmentation risk, right?
Yeah,
I don't know. You want to start? Yeah, you should.
Yeah, I think it's a double-edged sword.
Yeah.
So if you use it properly, it can enable innovation. So the thing is that if you have an extension which you eventually want to democratize, make it available to everybody through standardization process, so that is where it will become it will accelerate the innovation. It will solve the immediate problem with an eventual goal to kind of make it available for all.
So maybe I think if I'm to interpret what you're saying is the problem which Albert initially mentioned, hey, I have a customer requirement, I have two competing ways of the data coming in. So maybe your thing is, hey, you know what? Initially, the tool just makes it in a non-standard extensions, make sure you get through it, and then see if you can get it back into the standard. Maybe I'm probably.
Yeah, and I can cite few examples of that. Like there was a time when we needed some extensions to identify like the soft IPs in the system so that we can identify the boundaries around it and so that we can scale our tools better. But at that time, the UPS standard did not have any capability to identify or mark the soft IPs and all. So we went ahead and used the custom attributes that the UPF provides to kind of define a terminal boundary attribute, which was there to address the immediate customer requirements. We immediately, once it was added, we found that it was really helping customers and also then we worked with the customer and also worked with the IEEE committee and standardized it, refined it further, and now it is available as a refinable macro, which really basically was a part of the UP 4.0 that came out this year. And it is about we start with a proof of concept, we then see value in it, we democratize it, make it available in the standard so that everyone can.
So you're clearly coming off, hey, it's an enabler. You're still sticking by your point. It is actually an enabler and not a fragmentation risk.
If you look, basically aim to standardize it in future, not want to be in a silo.
Correct. Yeah. Because again, initially what we were hearing, the first time, again, this is way back, right? I remember the UPF initial discussions where a lot of customers coming and saying, hey, each tool, it's not a standard anymore where it's got so much of a Cadence specific, Synopsys specific stuff that it's not a, but again, in this case, you're saying, hey, if you manage it well, that's plus.
That is right,
yeah. And also, I think another aspect also have to be considered is because we are providing software to a customer, their design is getting bigger and bigger. So the efficiency of getting data from those standard libraries, whatever, it's very, very important. Like, for example, in some cases, we have to get some waveforms if it just taking a lot of disk space to store that. And also on the fly, we probably have to do some interpolation and to get, for example, for the EMR, we have to calculate also all those current points and do the analysis. If there's a standard in a way that store it, but the efficiency is really bad, customer won't have it, because in the end, is for their point of view is they do care about turnaround time, right? So I think that's also aspects that when we design all these standards, we have to take in consideration is if we make the standards too complicated, not that efficient, and there's going to be a roadblock down the road to adopt those.
Okay, fair point. Yep.
I'd like to add to Albert's point. I think the scalability to any standard is very important. The solution has to scale from a tiny IP all the way to huge
Full
chiplets, really, right?
Valid.
And that's
okay. Very good. I think good points. So last mini debate before we move to the next section, right? So I think we'll touch on this aspects, but are today's standards agile enough for, again, I'm going to frame it under a modern AI hardware needs, right? I mean, so I know, Sri, you had some very strong points on this. I know we've probably discussed. You want to start?
So, are the standards agile enough? I mean, I agree, it's not keeping pace with the times. That part I agree. But does it need to be as fast as an AI, for example, like give it to you in a matter of minutes or seconds? Not really. The point of the standard is not about just speed. It's about making it interoperable, making sure it works with everybody, make sure it works with so many end-to-end cases, really, right? So it's not purely speed that's important. It's also important to make sure it's interoperable and all the parties are actually on board. Right.
Okay, Alid?
Yeah.
Who else? Yeah, please.
Yeah. So basically, while it is true that formal standard takes time to build consensus and get it ratified with everybody and bring it out, but we have to see that if the standards provide some mechanism, like I was talking earlier, like if they provide some custom extensions which can enable users to be within the scope of the standard and still address the immediate requirement with the eventual goal of standardization, that is kind of enabling the innovation as well. Like, for example, the refinable macro I talked about, it helped us immediately solve a problem and then eventually standardize it. So I take it as a POC to POR journey where you address the immediate innovation by a proof of concept. Then if it is successful, if it is giving value, then you standardize it and make it a plan of record, basically by being part of the standard. Having said that, I want to highlight one more example that was basically that we experienced in UPF is that if we are able to, let's say, build up consensus within the UPF committee and we agree, okay, this is how you can solve a problem. We don't need to wait for the final standard to come out. We can go ahead and proactively implement it in the tools and with the understanding that, okay, we have already agreed on the semantics and it will eventually be coming out. And that way we can provide solution to the customers sooner than the standard comes out. And that actually happened in UPF. Like we had a request for specifying async clamp value feature. It's a feature where allows you to specify special kind of isolation cells. We agreed within the group, okay, this is how it should look like. And we went ahead and actually released that feature 2 years before the standard came out. So if we are able to build up concept, wait for the final standard, we can go ahead and do it. So with this, I don't see standards creating a roadblock. They are enabling AI innovation, but we have to acknowledge that it follows innovation. It's not, you start with a proof of concept and then you go to the POR.
Correct.
And that is how we should look at it.
So this kind of goes into my perceived next section where I wanted one to take a stance saying, hey, I'll take 2416 as an example. Hey, you had 2 revisions in 9 years, for example, right? Whatever, one coming out. Is it too slow? But I think what probably you're getting ahead of my session there saying that, hey, yeah, there is, there is validity, there is reasons, but we still have mechanisms built in to still, without the formal standard coming in, you still can keep yourself going. So I think that kind of got into my change my mind section, but that's a good segue. But let's hear from.
Yeah, I'll just say briefly, this question of this AI, sorry, the standards stifling innovation, I just don't think so. I mean, I think about some of these other standards that we use all the time, like Verilog and ditlef def and System C. I mean, I remember building chips before we had those, and it was painful. And once they came along and the standard was adopted, then we just kind of dumped what we were doing and we adopted the other one really quickly, and our costs went down. And so I kind of think the same thing about these other standards. I think the innovation goes on. People spend a lot of money because these standards don't exist. But then, if the standard kind of doesn't deliver, if the people who are developing it aren't on task, then it just kind of fizzles out and dies. But if they do stay on task and they deliver, then, there's very rapid adoption and everyone's costs go down. So I think that's what we're all aiming for.
Very nice. Albert,
Yeah, I think I think we agree with those guys. And on one side is the standard has to be flexible enough for us to act really fast to accommodate customer new needs and to innovate in that way. But also on the other side, I think having some standard even for us to develop internally also can help. I think, for example, for this AI model, I think there's a open format Onyx format. For us, like one customer like saying, okay, they have a 3D IC thermal issues. They want to consider using the thermal tool to guide their early stage planning for their 3D IC. To complete that project, I think just do the thermal analysis for every cycle is impossible. I have to come up with an AI model, build a 3D AI model, and then use that to connect it with the traditional floor planning tool and to provide thermal feedback to them. And if I don't have like Onyx format or some regular format, if I have to build all those AI-based infrastructure, it's gonna take maybe a year or two to deliver a solution to the customer. But having some of those open source data, not standard, but open source data library over there, it helps to come up with a prototype within a month, within several months. So, and to help the customer on their project. So I think that's another way to help us too.
So we do have a convert here, so that's very good. So that's very nice, right? So let's pause here, and we have a lot of folks in the audience, and let's see if we can have some sort of an interactive audience Q&A. If anyone wants to, please, Daniel.
So far, I'm Daniel Cross, Cadence Design Systems, also 2416 working group. So far, this discussion has centered around EDA standards, but we're actually seeing standards being developed for what AI should actually do and how it should behave. And so I'd like to get the panelists' takes on whether those standards represent a way to let people safely innovate around AI, or whether it's just an unnecessary constraint that keeps people from doing what they really want to do.
I think, Albert, you're kind of touching on this in your last point also, right? Where Onyx and other stuff, I thought, I don't know, maybe you want to take that, or?
I think on the general, all these AI innovation, the way they're coming up with different models and applications, I think personally, I don't believe like too much regulation over there can help on, because we all can based on the customer need come with the different ways of using those, right? But of course, I think from the safety point of view, it's good to have some really big envelope under to guide those. Yeah, but it is a very difficult way to try to strike a balance between not too regular, too restrict, and to open some paradox in the future.
Others?
Well, I was just thinking, software standards can become entrenched, but they can also be changed a lot more quickly than a hardware standard. When you're building hardware, you have a lot of upfront investment. You can't just change the code. And and you heard Michaela's talk this morning. I mean, she talked about how we're going to get 5 orders of magnitude reduction in power per inference or energy per inference. We're going to have to pull out all the stops. And so if we end up having some entrenched standards that help one kind of AI model, but not others, maybe we have a little bit more heterogeneity in our data centers, but I don't think that's going to be a huge problem.
Okay, interesting. Amit, any opinions?
I think software standards, are quite different from hardware standards in that for software, I think we can always build additional layers on top to kind of work around the problem or to kind of make it fit into other systems. But, with the hardware standards, it's quite different because it's really, you have to do this at the design level, really, right? So I think for AI, I think it's best we kind of let it freely go freely because there's a lot of room for innovation there.
Hey, thank you, Sri.
One thing
Go ahead, please.
I just came to my mind to think of is, if you look at the software point of view, it's almost like writing a novel, literature, right? I mean, it's really difficult for us to put the guidance like, okay, you can only write novel in this way, you can only write novel in this category, right? I think it should encourage people to explore the ways they're showing, they're describing their stories, they're using the language itself. But of course, on the bigger side, there are certain points that you don't want to encourage, like hatred or whatever. So I think this is more if in the future we're going to look at developing some AI guidelines, I think just by looking at the way we're encouraging people to look at the literature writing novels, I think there could be some similarity like we can look into.
Okay.
Yeah.
Interesting. Yep. Thank you. Please. Yeah.
So it's the Wild West, right? Now everyone's doing their fun thing. Okay, fine. What about ethical standards, issues about protecting IP, not having some AI regurgitate my IP to produce RTL, that kind of stuff. So my main question is ethical and safety standards. Is anyone doing anything about it for AI? Should they?
Good question. Yep. Brett, you want to start?
Yeah, I wish I knew. Yeah, these are hard questions. And most of us are in the physical design side here, so we haven't really been talking about LLMs. But yeah, I think that bears a lot of thought. I think that's probably one place where standards are needed. Standards are all about bringing people together with diverse interests, and I think that if you don't have a diverse group that's creating benchmarks, creating standards for this sort of things and requirements, then yeah, I think it's probably going to end up just like you said. It's probably going to end up pretty unfair. And so that's one place I think it's really needed.
Right. I mean, it goes back to a conversation I was having with Marshall just a little while back, where he said, yeah, I mean, where are the guardrails for the LLMs in terms of, what goes in, what goes out? It knows open access commands, it can generate open access code, but I don't know anyone who's probably supposed to have even started that. I think that's valid. I don't think any of us probably have a valid question, but that's a lot of examples of those things which should go hand in hand, right? I mean, as we are in this world. Yeah. But if anyone else had, yeah, please.
One more point. So I think that's a very important consideration what you brought up. I believe the AI systems should be developed with security in mind. And, I'm kind of putting it in a different angle, but same thing as ethical or moral standards there. Because what is acceptable, what is not acceptable from a ethical standard or a security point of view has to be a foundation, for AI. If that is not built, from that point of view from the beginning, it can lead to really, really dangerous situations, right?
Great. Thank you. We have one more question, please.
Yeah, so the name is Dhanwada from Siemens EDA as well. So my question is actually, we talked a lot about software and hardware standard, but actually when we talk about AI, ML, they are learning from data. So the bigger elephant in the room is actually, do we have any data standard established by SI2? And if the history has anything we can learn from it, like ImageNet established the standard of people competing against each other about benchmarking their neural network, deep neural network, about image classification.
Yeah.
It started the revolution of deep neural network. So the same, I know SI2 has started something like established the benchmark standard for Verilog language. You are doing that. So do you have any additional activities on data standardization and benchmark of large language models and AI agents? You know, everybody is talking about agents, but how do we evaluate which one is better?
That's an excellent question. Who's the closest to the AI ML in SI2? There's Red.
Well, I'm glad you brought up the
Yeah.
the NVIDIA effort, because that was the first one I was thinking about
Yeah.
as you brought it up, and I think that's an excellent example. I think we can also talk about the AI schema.
Maybe Red, you should elaborate what the NVIDIA example
Oh,
is.
okay. Not
Okay.
right now. Okay.
Okay. So,
Thank you.
go ahead.
I'm Leanne Clevenger with SI2. This afternoon, we're going to get a presentation on this very subject at our members meeting. So anyone who is an SI2 member company, you're welcome to join. If you're not in an SI2 member company, talk to me and I'll get you a guest pass. So we'll get more information on that this afternoon. I don't
Right
want to
here.
get us off topic. It's right here.
Okay, but without that, you can still comment.
But without that, I mean, I think a lot of this has to do with what companies are willing to contribute. Because if, I mean, it's kind of like passing the hat. If everyone is developing their data sets and they're trying to use it to develop their own product, which they're going to try to edge out their customers for, then you're right. There's innovation is going to be held back. ImageNet is a great example of someone saying, you know, I think there's a bigger market here if I don't hold this back and I share it. And I think that if we can encourage people to make more of those contributions, then I think we'll get a lot faster innovation.
Okay, point. Please, Andrew.
Not a question, but to the previous gentleman's point, at this evening's Birds of a Feather session on open source EDA data and collaboration, there will be an entire session with speakers from Drexel and Arizona State exactly on the subject of what the question asked. So please feel free, room 3001 at 6:30.
Perfect. There you go.
Should have mentioned that one too.
Okay, so I know. Any other questions from anyone? Yes. No. Once, twice. Okay, that's perfect. So let's get into the last part of it, right? So here we are. So let's try to 5 minutes, right? I mean, a collaborative standards wish list, right? I mean, let's start. So what's one thing, I don't know, you wish 1801 supported? I'm going to pick on the existing standards. I mean, let's try to,
Whether it's 1801, 2416, right? I mean,
yeah.
My wish list has always been for PD and EMIR solutions that there's really no standardization.
Yep.
And that's something I think we try to pitch into 2416
we should address it,
to kind of bring that standard.
Yeah.
Right.
I mean, I agree with
and
you.
That's going forward, it's even more important with the chiplets and all these designs.
Correct.
How I'm actually going to tie these systems together.
As Albert mentioned, there's XPGV, there's PGV, there is something else from ANSYS, there is a lot of stuff. Absolutely, very well. We should take that down. Yep.
So
Amit.
Yeah, so I think one wish list which I believe like we could add in the 1801, in fact, is Currently, the UPF standard or 1801 is basically gets applied when the designs are fully elaborated, which means that the scalability is a bit of challenge, like you were mentioning earlier, that you want the standard to be scalable. So my wish list is that if we can make UPF more modular so that it kind of scales with the number of models and not the number of instances in the design where like the designs are replicating, the instances are multiplying. So that is what I believe is my wish list. And I believe we are working towards it.
Okay, but it also needs some rethinking, fundamental rethinking also, right? That's okay. Good point. Brett.
Well, yeah, hard to say. I think a lot of comments that were made here about fairness in AI is probably one of the biggest issues that but unfortunately, I'm not really much of an AI researcher. I mean, I do AI for EDA, but you know, there's not much fairness when you're considering how to place blocks. I think in terms of something that's more immediately applicable to me, I really wish that we had better support for 3D in OA, and that's why I'm looking at Marshall Tyner over there.
Okay.
I think we've got some great starts in that, but I think we could do more.
Okay. Albert.
So my final thoughts on the standards, as to summarize what we discussed, I really hope that standards going forward can be more consider flexibility, scalability going forward, so that will make a much easier adoption. Yeah.
Got it. Perfect. Anything else from the audience in terms of a wish list beyond probably some of the questions we heard? Daniel is smiling. Okay. All right. Okay, let's go.
So we've heard from the big EDA companies and the big design companies. I'm very interested, and there may be some folks here that fall in this category. I'd love to hear from the startups. What is it that is going to, and again, open access is something that we have put in place. We have a lot of startups taking advantage of that standard, but what are the standards that really are going to help the startups be able to accelerate their development? So I'll add that to the list.
That's really fantastic. Okay. Andrew, did you?
Leon sparked a comment from me, which is that, I mean, ultimately it's freedom to operate, right? There's interoperability and there's obvious tensions between business uniqueness and silos and, you know, protecting one's fortress versus the universal ideal of interoperability and flexibility and so on. So I think the style or the playbook has converged in a very converged ecosystem. The question is a little bit of openness and freedom to operate, and all of these torpedoes that are under the water running deep, like SDC or P cells or SVRFs. I mean, the list is long. So can the industry agree to disagree, but allow operation? And I'll call out a few of those. I mean, the ones I mentioned are like poster children for this.
Valid.
Can there be open alternatives that at least are agreed to be allowed to exist?
So you want some ladders in the walled garden for you to scale. So
not necessarily scale in a bad way, but
no, I mean, yes,
but because the ecosystem as a whole, which is going to be $1 trillion, and you know, EDA IP is not that large, relatively speaking. I mean, those should be allowed to move forward. And I think there's some obvious suspects. I wonder if there can be agreement at least on those.
Perfect. Perfect. Thank you, Andrew. Yep. So I think we're at almost at the end. Give 30 seconds, closing statements, starting with you, Sri. We'll wrap it up.
Yeah, just to close, you know, as an IP provider, you know, our biggest goal is to build an ecosystem, a flourishing ecosystem, and I think standards are the way to do that.
Great.
Yeah. So circling back to my earlier comment that standards are about democratizing the technology. They follow the proof of concept and make it a plan of record. So I believe they create a stable foundation for the AI systems to kind of innovate from there on.
Great. Thanks, Sumit. Right?
Yeah, I actually wanted to just touch on Andrew's
Andrew's
point at the end there about the torpedoes under the water. I think that's a big problem. I think that's something we need to do something about. I actually wanted to call out Siemens as an example of a good solution to this. You know, when we published our first free PDK, they contacted us and said, you know, you can't do that because we own SVRF and you're infringing on our rights. And at first I got really angry, but you know, it turned out to be not so bad. They said, no, just put a click-through license on there and everything will be fine. And I really appreciated the fact that, you know, they set a clear boundary and they said, you know, don't do this and we're not going to bother you. And I think that's the thing, you know, we need people to say, here are the boundaries, don't cross those and innovate away rather than just, you know,
Stopping or making it.
waiting for something to happen until, you know, until a startup gets valuable and saying, hey,
Perfect.
I'm going to sue you.
Good. Thanks, Fred.
Yeah. So I think in one side, on one side, I think a standard can help to democratize the tool development, but also help invite some innovation. But on the other side, the standard has to adapt really fast to all the industry changes and make it flexible and scalable, and also consider business side to in order to make it prolonged.